Okay. So in order to find our area, we will use an integral. And generally what we want to do is we want to make sure that by graphing the function or looking at the graph of the function, or just by knowing what the function looks like, make sure that it's continuous on the entire interval and look for any places where the function might cross through the x-axis. Because if we have any places where the function crosses through the x-axis, right, like this, let's say, if we're integrating from here to here, the integral itself, I guess I should make that extend to here. These values, the integral is negative. And these values, where it's above the x-axis, the integral is positive. And so if there are any sections that are below, we've got to integrate those separately, find what this value in the middle is. So here's A, here's B, here's C. Integrate from A to B, make that part the opposite of what you get from the integral, and then integrate from B to C and add them together. Okay, so only important thing here to recognize is that these integrals that are below are negative values. So those areas still need to be positive. Good?
Why'd you skip number 2?
I did. Because I wanted to. Seems like the right thing to do. You see, because I'm number 1, and all the rest of you are so far below me that there was no room for number 2. Or something. I don't know. Good question. I skipped number 2. Although I did say if either 1 or 2 is true. I should probably say if I don't know. You get the point. I don't know. Let's do this problem. Stop pointing out my deficiencies. Let's find the area of this region bounded by the x-axis, x equals 2, x equals 5, and the function x squared plus 1. Sound good? What's the graph of this look like? I am, Derek, don't worry. It was just a test to see if you guys would notice.
You said it was a deficiency.
Yeah, I just said that to make you guys feel better about yourselves.
Oh, okay.
Yeah. All right, here's x squared plus 1, right? And from 2 to 5, we know that this is always going to be above the x-axis, so we don't have to worry about any places where it's going to cross through the x-axis. So in order to find this area, all we have to do is integrate from 2 to 5, the function x squared plus 1 dx. Easy enough, right? What is the integral of x squared plus 1? That would be x cubed over 3 plus x. And we got to evaluate that from 2 to 5, which ought to give us, what, 125 thirds plus 5 minus 8 thirds plus 2. And what does that come out to be? 125 thirds minus the 8 thirds minus 5 minus another 2 minus 7. That comes out to be 42. Somebody check that arithmetic and see if I'm actually don't check. It's
Wait, shouldn't it be plus 5?
Yeah, it's plus 5.
Everybody good with that?
Yep.
Great. Let's do another one. That was easy, right? Now we'll do some that require us to like remember some of the rules that we need to know. So we're going to look at the integral from 2 to 3 of the natural log of x minus 2, and we want to find the area between the curve and the x-axis. So tell me about natural log of x minus 2.
At least for that portion, it's going to be below the x-axis.
Right, so we're gonna know this is always below the x-axis. You could either graph it to see that, or you could just know that the only way for me to get, this crosses the x-axis when x is equal to e squared. And so e squared is clearly a lot more than 3. So we're going to, and all the values greater than e squared will make it positive. So all the values less than, they're going to make it negative. So we know it's below the x-axis. So we want for the area this to be the opposite of the integral from 2 to 3 of ln x minus 2 dx. And hopefully now you remember what is the integral of natural log of x. This is one I told you to memorize. What's the integral of natural log of x?
It's like x natural log x minus x, I think.
That's exactly right. And then the integral of the negative 2 is minus another 2x, evaluated from 2 to 3. If we wanted to combine those together, we could. That's really a negative 3x, right? So now we've got the opposite of 3 natural log 3 minus 9 minus 2 natural log 2 minus 6, which should be 3 ln 3 minus 2 ln 2 minus 3 with a negative in front of all of it. And if we were to simplify that all down and distribute the negative sign through it all, we'd end up with, that's natural log of 4, that's natural log of 27, should be a natural log of 4/27 plus 3. That sound good? Or you could just write it as do natural log 2 minus 3 natural log 3 plus 3, but however you want to write it is good. Good or no? Using your log rules to simplify it down?
All good.
Wonderful. All right. Let's see if we can find the area between the x-axis and this curve, x squared minus 4x plus 3 over x squared minus 4x plus 5. What do we think? What do we need to do first?
Should divide.
Now, before we even divide, we got to figure out about whether or not we need to separate this into separate integrals, whether it crosses through the x-axis at all. So how do we determine if this has any x-intercepts? By factoring the
Top.
Right? So that's going to be x minus 1 and x minus 3. So it sure looks like it's got x-intercepts at x equals 1 and x equals 3. And if I plug in something less than 1, like 0, I get a positive, so I'm above the x-axis. If I plug in something between 1 and 3, like 2, I'm going to get a negative on the top and a positive on the bottom. And so I'm below the x-axis. And if I plug in something more than 3, like 1,000, I'm going to have positive and positive. So it looks like it crosses through at 1 and at 3, right? It doesn't just bounce off. So the area of this should be the integral from 0 to 1 of f of x minus the integral from 1 to 3 of f of x plus the integral from 3 to 4 of f of x. So make sure you check and see when it crosses through the x-axis. Good? Okay. So now, yes, we want to do the division. Since this is a rational function, there's no simple u sub, and the degree of the numerator is equal to the degree of the denominator. So we will divide the x squared minus 4x plus 5 into the x squared minus 4x plus 3, giving us a 1. So we'll say, in fact, we should probably write the integral of f of x dx should be equal to the integral of 1 minus 2 over x squared minus 4x plus 5 dx. And how do I integrate 2 over x squared minus 4x plus 5 dx?
Complete the square.
Yeah, complete the square with it. Good. So this will become x for the first part, and then minus, and we'll say 2 times the integral of dx over x squared minus 4x plus 4, right? We complete the square as an x minus 2 squared plus 1. And so what's the integral of that? That's u is equal to x minus 2 with the du equal to dx. You can do the u sub in your head, hopefully. Gives us x minus 2 inverse tangent x minus 2. So that's our indefinite integral if we added a constant to it, but I'm not going to bother with the plus a c because really we need this for 3 different definite integrals, right? Everybody good with that so far?
Yep.
Okay. So from 0 to 1, maybe I should write out. What do we have? We have x minus 2 inverse tangent of x minus 2. So from 0 to 1, that should be 1 minus 2 inverse tangent negative 1 minus 0 minus 2 inverse tangent of negative 2. Everybody agree with that?
Yeah.
Okay, and from 1 to 3, we had an opposite of, if we plug in 3 to that, that should be 3 minus 2 inverse tangent of 1 minus, and then 1 minus 2 inverse tangent of negative 1. Yeah. And from 3 to 4, we ought to have 4 minus 2 inverse tangent of 2 minus 3 minus 2 inverse tangent of 1. Everybody agree with all of those? In my atrocious handwriting? So now we just got to add all those together, right? So 1 minus, what's the inverse tangent of negative 1? The inverse tangent of negative 1 is
pi or 3 pi fourths. Oh no, yeah, 3 pi fourths.
no. Whenever you take an inverse tangent, you always get out something between negative pi over 2 and pi over 2.
Negative pi over 4.
Negative pi over 4. So the inverse tangent of negative 1 is negative pi over 4 times negative 2 is plus pi over 2. Minus 0, that'll go away. And then we have plus 2 inverse tangents of negative 2, which we probably don't know the value of the inverse tangent of negative 2, so we'll worry about that in a bit. And then we've got -3. And then we've got plus 2 inverse tangents of 1. What's the inverse tangent of 1?
Pi over 4.
So we have plus pi over 2 then, since it's 2 of them. Then we have minus a minus here, so that's going to cancel it out. And so we're just going to have a +1. And then we're going to have a minus 2 inverse tangents of -1. And the inverse tangent of -1, like we said before, is a negative pi over 4, which will cancel with this negative, which is 2 times pi over 4, which is plus another pi over 2. Oh, I forgot to write my +1 plus that pi over 2. Everybody good with 1 to 3 getting in there? Okay, and then we have a 4 minus 2 inverse tangent of 2. And then we have a -3. And then we have a minus, which makes a positive. Inverse tangent of 1 is pi over 4 times the 2 is plus another pi over 2. Good or no? So what do we have? We have 1. We have -2. We have -1. We have 3. We have 0. All of those other constants cancel out. Then we got pi over 2 and pi over 2 and pi over 2 and pi over 2, which ought to give us 2 pi. And we have plus 2 inverse tangent -2 minus 2 inverse tangent of 2. And what do we know about the inverse tangent of -2 in relation to the inverse tangent of 2?
Are they opposites?
They should be opposites of each other. So the inverse tangent of -2 should be the opposite of the inverse tangent of 2. So we could call this 2 pi minus 4 inverse tangents of 2. Seems like a good value there. Good answer, yeah. Wasn't that fun?
To be honest, no.
Wow. I don't know what you think is fun then. Any questions on that? No? All right. What about finding the area between two curves? So if we want to look for the area between two curves, we just integrate on the interval, the upper function minus the lower function. Notice that I did put a number 2 in here this time. So first thing we have to do is figure out which curve is above the other curve on the interval, and then determine if they intersect on the interval. If they do intersect, you have to break it up and do separate ones for each one where they, where the first one is above the second one, and then second part of the interval, you'll do the other one is above the other one. Okay. And anything below the x-axis, you don't have to worry about. And then you just integrate. Easy enough? Or no?
Yeah.
All right. Wonderful. That's great. Okay. So let's see if we can find the area of the region between f of x equals x ln x and g of x is 6 minus x squared on the interval from 1 to 2. So first off, which one of these is above the other one on the interval from 1 to 2? I think
G of x.
Yeah, g of x ought to be above x ln x. And if you think about it, the lowest that 6 minus x squared is going to go is to 2, right? And the natural log of anything between 1 and 2 is going to be a value between 0 and 1. for sure. It's always going to be less than 1 and greater than 0, because natural log of e is 1 and natural log of 1 is 0. And so if I'm multiplying at most 2 by something that's less than 1, it's always going to be less than the largest value of this. So just using a little bit of intuition there, we could figure that out. And how do we feel about not doing all of these integrals, since we've just spent the last week and a half practicing integrals and just letting our calculator evaluate some of these? Once we get them set up, everybody going to be okay with? Yeah, we're all good with that. All right. So then you have a graphing calculator in front of you, I hope. Just use the integral function. I think it's math option 9, I want to say, to evaluate your integral. It should, with any luck, just pop up as the integral sign. Plug in your 1 and your 2, put in your function and your dx. Does anybody's come up without the integral sign, where it just says like FNINT parenthesis when you click on it? Oh, good. So you'll just evaluate this on your calculator and tell me what you get. What do you get? Oh, people already said it. 3.030. Sounds good to me. Units squared. Everybody get 3.030? Always round to 3 decimals or more. All right, let's see if we can find the area of the region bounded above by y equals 3, below by negative x plus 2, and by y equals the natural log of e times x.
Should we always say units squared after our answers?
Yeah, if we're talking area, sure.
Okay. All right, so we've got y equals 3. We've got y equals negative x plus 2. And we've got natural log of e times x. So that's just going to look something like that. And how are we going to find this area bounded by all 3 of those?
2 different intervals.
Yeah, we're going to have to do 2 different integrals. One will have to be an integral from wherever these intersect. Where do those intersect? When does negative x plus 2 equal 3? When x is negative 1. So from negative 1 to wherever these intersect, when does negative x plus 2 equal natural log of ex? A good thing you have a graphing calculator, right? I probably don't even need a graphing calculator for that. Where do those intersect? Looks like that's at x equals 1. You just sort of intuitively figure that out. If you plug in 1, that's negative 1 plus 2 is 1. And the natural log of 1e is just 1. So we'll go from negative 1 to 1 of the upper function 3 minus the lower function negative x plus 2. So that's going to get us first piece of it. And we will add to that an integral from 1 to somewhere else of 3 minus natural log of EX. And that one, to figure out where natural log of EX equals 3, well, that one will probably need a graphing calculator for. So where do those intersect? Graph them both and then second calculate intersect and then calculate the intercept.
Wouldn't it just be E squared?
Yeah, looks like it would be, huh? That makes sense. X would be E squared. Sure. Yeah, E times E squared. Yeah, that sounds good. All right, so 1 to E squared. And you guys okay with using the calculator to evaluate this again or no? What do we get? Oh, 7.389 and a 6.389. Which one of those is right?
I got 6.389.
Anybody else agree with that? 6 rather than 7?
Yeah, the 7 I think was in response to asking when ln of EX was equal to 3, because 7.39 is also equal to E squared.
Gotcha. That makes sense. Okay. Cool. And so we could probably note that this answer was E squared minus 1 if we'd actually gone through and found the exact value. Good or no? Everybody feel like they could do both of those integrals on their own?
Yeah.
I mean, this is pretty easy. This one, you just have to do a U substitution, natural log of EX, let U equal EX. Right? Okay. Cool. All right. Let's do another one. Let's see if we can find the area enclosed by these two functions. So if we're looking for the area enclosed by the two of them, what do we need to do?
Find the two places that they intersect.
Find where they intersect. So we need to set them equal to each other or graph them and see where they intersect. Might be easier to just graph these ones. So why don't you guys graph those and tell me where they intersect using your graphing calculator.
I got x equals 0, x equals 1, and x equals 2.
0, 1, and 2?
Yeah.
Alright. Sounds good to me. And from 0 to what?
I also got that.
All right, and from 0 to 1, then which one was above the other one? Should be able to figure it out if we want to. Probably.
G of x.
Yeah, g of x, that seems reasonable. G of x minus f of x, I'm not going to write them all out, because those are some annoying long functions. And then we will add to that the integral from 1 to 2 of f minus g. And I mean, if you guys already are good with plugging them into your calculator, I don't know, that's a good enough answer for me right there. For now, I mean, obviously, if this was a quiz or the AP test, you need to get a numerical value, but I'm good with that, as long as you are all conceptually okay with how we set that integral up. Everyone good with that?
Indeed.
All right, we'll do a couple more of these. We're going to do 2 more of these, and then we'll call it a day. So let's do a couple in terms of y. So we want to find the area of the region enclosed by y squared equals x plus 1 and y squared equals 3 minus x, or effectively x equals y squared minus 1 and x equals 3 minus y squared. And what do those look like?
Sideways parabolas.
Sideways parabolas, exactly. So what does y squared minus 1 look like? Which way is it opening?
To the right.
To the right. So here's y squared minus 1. And what about x equals 3 minus y squared? Should be opening the other direction and extending 3 units over here. And we would note then that instead of thinking about which function is above the other function, we're only going to think about which function is to the right or to the left of the other function. So anytime we are doing an integral in terms of y, it's always which function is to the right of the other function. Everybody good with that? Okay, so
Yeah.
which function is to the right of the other function?
Y squared minus 1. Or,
I
oh,
think
that's
it's the other way around.
up
3 minus y squared minus y squared minus 1 dy. And now instead of having limits that are in terms of x, we'll have limits that are in terms of y. We need to figure out at what y values these things intersect each other. So we will set y squared minus 1 equal to 3 minus y squared. That gives us y squared equals 2y squared equals 4, or y equals plus or minus root 2. So we'll integrate this from negative root 2 to positive root 2. Everybody good there?
Yep.
All right, just for the heck of it, let's do this one. So we've got 3 minus y squared minus another y squared is minus a 2y squared, and that becomes a plus 4. So negative root 2 to root 2 of 4 minus 2y squared, which is going to give us 4y minus 2/3 y cubed from negative root 2 to root 2. And what does that come out to be? 4 root 2 minus 4 root 2 over 3 minus negative 4 root 2 plus 4 root 2 over 3. And we should be able to simplify that out. 4 root 2 plus another 4 root 2 is 8 root 2. And then that's 8 root 2 minus 8 root 2 over 3, which ought to be 16 root 2 over 3. Good or no?
Wait, what? Isn't it like 8 root 2 minus 8 root 2 over 3?
Yep.
Was that equal to what you just wrote?
I hope so. 8 root 2 is 24 root 2 over 3.
Oh, okay. All right.
24 root 2 over 3 minus 8 root 2 over 3 is 16 root 2 over 3.
I see.
Good or no?
All good.
All right. Last one. We're going to get done early today. We won't move into polar stuff till tomorrow. So we want to find the area of the regions enclosed by x equals sine y and x equals y cubed. So what should we do first?
Find where those two are equal to each other.
Yep, find where they intersect each other. Okay. So when does sine y equal y cubed? You guys let me know when that equals, when those equal each other. So obviously one of those is y equals 0, right?
Plus or minus y equals 0.801.
Say it again. Plus or minus what?
0.801.
801. I feel like that's not right. Is that what other people got?
You want y values, right?
Yeah, I want y values.
Then I got positive and negative 0.929.
Okay, give me more decimals. That sounds better. I think it was closer to 1. Yeah, so 9 to what?
0.929.
Yeah, give me more than 3 decimals because it's not a final answer.
9286261.
9286261. You said?
Exactly.
All right, cool. And since we know that both of these are symmetric across the origin, we could do from the negative 0.928 to 0 and then the 0 to 0.928. But we could also just do, since those two regions are the same, we could double it up and just do 2 times the integral from 0 to 0.9286261 of the rightmost function minus the leftmost function on that interval. And so on that interval, I think sine is to the right of y cubed. Sean, you understand why that value is what your value is?
Yeah, I mixed up the x and y on my calculator. Sorry.
Okay, just want to make sure. Okay, everybody good with that? And obviously, since this is a value we're not going to plug in by hand, we'll use our calculator to get a final answer for this, which we can now round to 3 decimals if we want. What do we get? Anybody?
I got 0.215.
Did you remember to multiply by 2?
No, I did not.
I got 0.430.
Wonderful. 0.430 units squared. Everybody good with that? All right. That is our basic area stuff. We are going to stop there. Anybody have any questions on the area, doing it in terms of X, doing it in terms of Y, when they intersect with each other, when we're looking for the area between curves, when we're just doing one function? Everybody good with all of that, or any questions on any of it? Or? Everyone's good?